So today we are going to go through the data analysis for a receptor binding assay. When you read your plate, it comes out something along these lines. It just depends on what your plate reader's output looks like. But as you can see here, we have the first set up here is the background for the plate. So I read it before I transferred the reactions to the wells. And here's my data. And if you'll notice, the background, we're looking at about 20 to 30,000 RFUs, whereas my data is in the 2 to 300 RFUs. So looking about 10% background, and that's pretty typical for a plate reader. I've had plate readers have background in 100 RFUs and data at 1,000. It really just depends on what your plate reader looks like. So this is not standardized across all the plate readers, but 10% background is pretty typical. And I say that because if you happen to forget, as I sometimes do, to record your background plate, it's okay. Your data is still usable. You just can't subtract the background. But let's get started. Here, I'm going to delete out all these kind of extra things. I'll label this as background. I know what I'm doing. Label this as data. And then I have, this is my standard curve in triplicate, and I have my unknowns here. These wells I didn't have anything in, so I'm going to just delete out that empty data. Delete here. All right. So the first thing I want to do is subtract my background from my data. So I'll use the formulas in Excel to capture this well and subtract out the background, and then just drag that. Here's my standard curve. And then also I will need, just drag it over here to get my unknowns, but I'm going to go ahead and move my unknowns down here because I'm going to do some calculations. All right, so for my standard curve, I have my plate mat here at my desk, but this was 100 micrograms per mil of my standard. And then everything was a 1 to 10 dilution from that. So I calculate here my standard curve. This was 0 and this was 0. And I put these on the edges because sometimes plates can have edge effects and you don't necessarily want your good data, especially your standard curve, to be along the edges. And the zeros don't really matter that much, and you'll see why here in just a second. Because this is essentially, there's all of the binding sites are taken up by the fluorophore. So this concentration here at 0.001 micrograms per mil of brevetoxin is essentially 0 in the mind of the, if you're considering it in terms of the receptor binding assay. All right, so the first thing you want to do is calculate the percent of total binding. So total binding of the fluorophore is up here at technically 0, or at the 0.001. All of the binding sites are taken up by the fluorophore. So to calculate this, what we'll do is we'll grab this cell and we'll divide it by the average of all the zeros. But because I want this set of cells to stay fixed, I'm going to put $signs up here. So this is just a way to get Excel to hold that red group steady as you drag across and calculate percent of total binding for all of your data. And then because we like percentages, I'm going to convert this to percent. All right, so this is what I mean about edge effects. So all of these in this group here should be 100% as total binding, but as you can see, the RFUs are a little bit lower on the edges here at this set of zeros and this set of zeros. If this happens to you, there's a couple of things you can do. You can take the red block and kind of average across. I probably wouldn't do 0.01, but you can average across the 0.001 and that'll even up your percentages a bit more. Or if you're really low here, what you can do is use the 0.001 as the total binding. And so that's what I'm going to do here. And I'm going to delete out the zeros because you can see there. I mean, you can use them, you cannot. I'm just doing this for demonstration purposes. If you have like 80% total binding in your zeros, you've got a really bad edge effect. Maybe your plate didn't filter well enough, maybe you didn't wash it well enough on the edges, or maybe it's just a factor of the plate. But you can do this and use the middle wells, which are going to be more consistent for your calculations. And so it's not that big of a difference, but you can see here that works. All right, now what I want to do is take a log transform of my data. So I'm going to do log base 10. And I'm going to capture these wells. And that's another reason not necessarily to use the zeros, but to use, because you can't do a log of a zero, right? See, it gets confusing. It doesn't like that. So log transform your standard curve. And I'm going to start with the easy way to do this, which is to use GraphPad. So let's capture let's get GraphPad set up first. So you open GraphPad Prism. I love this program. It makes data analysis so simple. Your X value is just numbers, your Y is replicates, this is your percent. We have 3 replicates in this example, so I'm going to create my spreadsheet. Come back over here, I'm going to use the log transformed data for the standard curve, put it here, label this as log concentration of brevetoxin. Then I will capture my standard curve percentages. And then what works really well here is you capture your unknowns and you put them down here. Now there's not going to be a concentration here, but that's okay because we're going to use GraphPad to interpolate the data for us. So once you've got it set up, you click Analyze. Going to do a nonlinear regression curve fit. We're going to use the sigmoidal, and I have this in my recently used, but you can find it down here in these, the sigmoidal, where X is log of concentration. And then the important thing here is to click this interpolate unknowns from the standard curve at the bottom. You click OK, and always check your graph first. Graph looks great, nice little curve there. Like that. We're going to go to our results, and you want to go to the interpolated mean values, and here we have our percentage of total binding that we calculated in our spreadsheet, and here it has gone ahead and calculated the log of the brevetoxin equivalents that are in our sample. So I can capture that, bring it back over here. There's my calculation, and of course because it's a log transform, I'll take 10 to the little hat power of that cell, and here we go, like magic, your micrograms per mil in your 5 samples, your 5 unknowns. Easy peasy. But not everybody has GraphPad, so let's do it the manual way too, just so we have a nice comparison. I'm going to move this data down here so I have room. All right, to do that, I need to calculate the average of my replicates so that I can graph it in Excel. All right, I'm just going to capture this, the values, and graph. Scatter plot. And this curve, if you go back to GraphPad, it looks, so you still have this nice sigmoidal curve here, just like we did in GraphPad. Nice sigmoidal curve. But the problem is that it's going to be a lot more difficult to calculate it with Excel. So using it this way, over so we can see what we're doing. Let's insert a trend line. And I'm going to use a linear one, and you can see that there's more options here. We want linear, and I'm going to display the equation and the R-squared value on the chart. So the R-squared value is not that great, and it's because it's a sigmoidal curve, not really a linear curve. So to make this fit better and to make our data accurate, what I'll do is delete out the points where it's outside of the linear range. So you can see these 4 middle points are more or less linear. You start to get the sigmoidal tapering responses here at the -3 and at the 2. So if we delete out those values, we get a nicer, oh, that's very nice, an R-squared of 0.99. So that's pretty good. Now the problem with this is that if you have data outside of your range here from 98% to 33%, it's not going to be accurate using this method. So if you, here we can see, and you're going to see here in a minute once we calculate it this way, but these values are outside of the range of this linear curve. If that happens, then you'll need to delete your samples and rerun the assay. And if you choose to do this, I would probably recommend adding some points here in the middle, just so we get better data in the linear range. So instead of doing a 1 to 10 dilution, you can do maybe 1 to 5s or 1 to 2s here in between these spots, just to get more granularity of your data in the linear range. But here, this is where we're at right now. And so to calculate our values from this, we use the linear curve here. And let's, so Y is your percentage. Here's your Y value, right? All right, to calculate what this would be, we start by capturing this cell. We're going to start with the 30%. We subtract the y-intercept, or the b value, which is 0.5699, and then we divide by the slope, which is negative 0.2168. All right, so remember, this is log transformed, so we have 1.2, and 1.2 is in between these values, so that's where we're getting into that. It's not going to be as accurate because we had to drop off between the two values. So if it that right there is a red flag, I would take that and run the assay. All right, so now we can drag across and it calculates our values for each of these. And then remember, this is the log concentration of your unknowns. To get the concentration of your unknowns, you do 10 to the log power, and here we go. Here's our samples. Now what I want to do here is, you could see these are the values that GraphPad calculated. I'm going to take the average of these manual calculations, and you can see where some are very close, right? 1.29 is very close to 1.23, and that's because sample 3 here is within our linear range of our standard curve, right? 0.32, 0.22, those are pretty close, but that's, you're getting a little higher, so those in the midpoint are always going to be more accurate, and that's why I say you probably want to put a couple of points around here just to get that curve, but that's pretty close to 54 to 25. That's a lot further off. It still works because we're close here. Let's see, the log value is about 1.4 or so on average. This one's about 1.3, 1.2, so it's close to 1. 1 is a point in our standard curve, but because we're getting outside of that, you start to get some increase in or decrease in accuracy there. So I would recommend, again, putting points in there, or diluting your sample so it just stays within the linear range of the curve. But this is 2 different ways you can do it. This is, of course, the GraphPad way is a lot easier. GraphPad way here, the manual way here, a little bit more complicated, but it still works and you can get your data that way. So please reach out, let us know if you have any questions, and thanks for watching.